Hey there, kids. Guess what? We're going to talk about sum and difference formulas, specifically this sum and difference formula. As an example, we're going to be finding the sine of 75 degrees, but whatever. Now, since this isn't on our unit circle, and it's kind of hard to use the double or half angle formulas, we're going to split this into two different numbers, and then use this equation to find the sine of 75. So the sine of 75 is the same thing as the sine of 45 plus 30. Alright, now, this equation up here lets us know that the sine of 45 plus 30, 45 plus 30 equals sine of 45 times cosine of 30. And now, this plus or minus here, since it's sine matches. So it's cosine of 30 plus cosine of 45 times sine of 30. Yes. And now, since these are all values that are on our unit circle, we can figure this out pretty easily. So this turns into square root of 2 over 2 times the square root of 3 over 2 plus the square root of 2 over 2 times 1/2. There you go. That's simplified using your unit circle. Now we just have to actually multiply this. So square roots, you can actually just square them, or multiply them. 2 times 3 is 6. Square root of 6 over 4 plus square root of 2 times 1/2, that would be square root of 2 over 4. Yeah, because square root of 2 times 1, or 2 times 2. Square root of 2 times 4. So that, and now to combine these together, what you get is square root of 6 plus the square root of 2 over 4. And that is your final answer. That is the sine of 75. It's your exact value. But now, let's talk about cosine, right? You knew I was going to do that. You're catching on, I'm sure. You're intelligent. Alright, so for cosine, we're going to use a different number as our example. We're going to find the cosine of 105. Now, minor difference to note with cosine is that with cosine, let's say if it's a minus b, then it will be cosine of a times cosine of b minus sine. No. See, I've done it wrong. It's confusing. If cosine of a minus b is equal to cosine of a times cosine of b plus sine of a times sine of b. Cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. Which is why it's actually worth writing this one in its full form with two equations, but I don't have space for that, so whatever. So cosine of 105, we're going to split this one up into 60 and 45 degrees. So cosine of 60 plus 45 equals cosine of 60 times cosine of 45 plus minus sine of 60 times sine of 45. That is a 60, yes. And now using our unit circle, we're going to write all of this down in its proper form. So that becomes 1/2 times square root of 2 over 2 minus square root of 3 over 2 times the square root of 2 over 2. Now I can combine these just like we did for sine. So 1 times the square root of 2 minus the square root of 2, and 2 times 2 is 4. Square root of 2 over 4 minus square root of 6 over 4. So what we have here, in its final form, is square root of 2 minus the square root of 6 divided by 4. And that is your exact final form for cosine. I mean, see, simple stuff. Now, for the complicated one, the one that I screwed up writing several times. Tangent. Tangent is, it's interesting. It's an interesting experience that you will get to experience, I suppose. So for tangent, we're going to make this really difficult for ourselves because of masochism, and we're going to find the tangent of pi over 12. Now, pi over 12, actually, it's really simple to find. Let me show you over here. So basically, you know, so normally, let's say if we have 105, we split that up into 60 plus 45. Well, pi over 12 is the same thing. We're just going to split it up into, so here's pi over 12. That's an awful pi, but whatever. Pi over 12 is equal to pi over 3 minus pi over 4. Because, as you can see here, it's written down, if you convert these all into 12ths, pi over 3 is 4 over 12, minus pi over 4, 3 over 12. So it becomes essentially 4 minus 3 equals 1. So you just are left with pi over 12. So that's what we're going to do over here. Now, so this pi over 12, we're going to write as tangent of pi over 3 minus pi over 4 equals tangent of pi over 3 plus tangent of pi over 4 divided by 1. And now, let's see, we've got a nifty little plus or minus in this equation here, and in this case, this is going to be 1 plus, because it is minus over here, and that's how it works with the tangent. It becomes 1 plus tangent of pi over 3 times tangent of pi over 4. It's now using our nifty little unit circle, which is our true Lord and Savior. We're going to substitute all of these values, and we're going to get square root of 3 minus 1 divided by 1 plus the square root of 3 times 1. Now this can actually just be, because I know it's the square root of 3 times 1, so this can just be written as square root of 3 minus 1 divided by 1 plus the square root of 3. That is a 3. So here's where we're at so far. And now we have to finagle it a little bit. Because, you know, we don't exactly like this. So, what we're going to do is we're going to multiply this whole thing by the reciprocal of our denominator. So we're going to multiply it all by 1 minus the square root of 3 over 1 minus the square root of 3. And that gives you square root of 3 minus 1 times 1 minus the square root of 3 over negative 2. That's after all of the foiling and combining like numbers and all of that shenanigans, because that's a lot to write out, and you can do that. So from here, what we're actually going to do is we're going to factor out this negative 1. Right, it's going to come out and come over here, and it's going to turn into a negative 1 times 1 minus the square root of 3 squared, still divided by negative 2. And then we're going to expand on this square, so it's going to be negative 1, I use double parentheses here, times 1 minus the square root of 3, 1 minus the square root of 3, like that. Looks confusing, but it's just a lot of parentheses, that's all. Alright, so we're going to write out this big giant number. Still got this negative 1 at the end, and we're just distributing it into all of these things. Negative 1 times 1 plus 1 square root negative 3, well, negative square root of 3 minus square root of 3 times 1 minus square root of 3. And this is negative square root of 3. Because this is what happens when you FOIL, kids. It's messy. We're still all over negative 2. So we actually haven't touched this negative 1 out here. We've just been FOILing this in here because it's 1 times 1, and then 1 times square root of 3, and all that. Now, if we simplify all this down, more like terms and stuff, we end up with negative 1 times 4 minus 2 square roots of 3 over negative 2. Now, we are so close to being able to deal with this. All we have to do is factor this thing out, right? You take it out here. So then it becomes negative 2 times 4. 2 times... Oh, wait, now. What have we done here? Oh, this isn't 4, this is a 2 now. Yes, negative 2 times 2 square roots. 2 minus the square root of 3. Yeah, because when you take out this 2, you have to divide this 4 by 2, so then it becomes 2 minus the square root of 3. And we're not factoring out the negative, we're just factoring out the positive 2. We're leaving that negative there because it gets multiplied by this negative 1 over here. That is what we have done. Here, negative 2. So then you'll notice, we now have a negative 2 divided by negative 2. We can just cancel those out, and we're left with our final answer, 2 minus the square root of 3. Which is lovely. So yeah, a lot of FOILing. Just when you're doing it yourself, you have to write it all out, and you end up with giant chains of numbers, like I did here. But that is, that's how you tangent and sine and cosine sum and difference angles. I did it all in one shot. I'm proud of myself. Be proud of yourself, because you watched this whole thing. Have fun mathing.